Continue with our binary search series. Today I will solve question 2064, minimize maximum of products distributed to any store. We are given an integer array called quantities. This represents the products that we have to distribute to a number of retail stores. A store can only be given at most one product type, but we can distribute any number of amount of that product to that particular store. Let X represents the maximum number of products given to any store. We want to minimize the maximum number of products given to any store. This question is very confusing to me, so let's do an example together. Suppose we have two product types. Product type 1 has 11 items, and product type 2 has 6 items. And we had to distribute all these products to 6 stores. Now, one way to distribute this is that store 1 gets 1 item, store 2 gets 1 item, and so does store 3, 4, and 5. Each gets 1 item of type 0. So we still have 6 items of type 0 and 6 items of type 1 left. So we're going to distribute these products to store number 6. Now, this does not work because the question stipulated that each store be given 1 product type. Here, the store 6 gets 2 product type, so this is clearly a violation. Let's try a different type of distribution. Suppose here we have store 1 gets 7 items of type 0, and then store 2, 3, 4, 5 each gets 1 item of type 0. So now we have only type 1 left, and that has 6 items, and we're going to give all the 6 items to store 6. This distribution, the maximum number of items for these stores is 7. Let's try another way to distribute these products. Suppose store 1 gets 2 items of type 0, and store 2, 3, 4 each gets 3 items of type 0. And then that we have 6 items of type 1 left, and that 6 items, we're going to evenly distribute them between store 5 and 6. Each gets 3 items of type 1. In such distribution, the maximum number of products for these stores is 3. The questions want us to minimize this maximum number, and that is the goal of the question. This question seems to be very difficult because there are so many different permutations of how one can distribute different products to different stores. However, if our goal is to minimize this max number, the intuition is that we distribute all the products equally across different stores, such that each store will get the same number of products or similar number of products. If every store gets the same number of products, what should that number be? First, let's consider what is the minimum products one can distribute to each store. Each store needs to get at least 1 product, so the minimum product for each store is 1. How about the maximum number of products each store can get? Well, the maximum product each store can get is the maximum of the quantities array, because each store is only allowed to get 1 product type. We can at maximum give all the products of that product type to 1 store. So the maximum number of products a store can get is the maximum value of the quantities array. In this example, the maximum of this quantities array is 11. For any particular store, the maximum number of products that store gets is everything in product 0, so that is 11. Now that we have one strategy, and the strategy is to try every number of products from 1 to the maximum of the quantities array. As long as we enforce the idea that every store gets only 1 product type, using this strategy, we can find the solution that gives us the minimized maximum number of products that are given to any store. If you have been following this series, you will immediately recognize that since we have a linear search strategy, we can always upgrade that to a binary search strategy. The range is the same. We're going to do a binary search, and the range is that we're going to distribute products from 1 to the maximum of the quantities array, and we're going to find the answer that way. Let's start pseudocoding this solution. We start with the binary search template. We have the low as 1 and the high as the maximum of the quantities array. And we also have a response parameter in which we're going to return. We're going to set the response parameter to be -1. So while low less or equals to high, we're going to get the mid value. The mid value will be the number of products that we're going to distribute to each store. And we're going to test this mid value, the number of products per store, whether that works using this can work function. In addition to the mid value that we are passing in, we are also passing in the quantities array and also the number of stores that are given to us. If this does work, then we're going to assign the mid value to be the response parameter, and we're going to set the high to mid -1 because we want to see if we can find another lower value. Else, if this does not work, then we're going to search the upper half of the range. We're going to set low equals to mid +1. And finally, we're going to return the answer. Let's talk about this can work function. This will take in the quantity, so the number of products, and also the number of products that we want to give to each store. This is the item value. And then the total number of stores that we had to distribute all these products. We will have a need store initially set as 0. So this value, we're going to compute all the stores that we need if we're going to distribute the products with the value that is in the items parameter. So we're going to go through each product in the quantities array, and then this quantity -1 divided by item +1. This is a little bit not very intuitive, but basically this is taking the ceiling of an integer's division when we divide the quantity over the item. If the need store value is exceeding the total number of stores that was given to us, then we know this is not going to work, so we will return false. Otherwise, we will return true. Now let's go over with one example. Suppose the quantity is 11 and we want to distribute 3 items to each store. 11 -1 over 3 plus 1 is equal to 4. We need 4 stores to distribute the 11 items. The distribution of products in this case will be 3, 3, 3, and 2. Another example, suppose we have a quantity of 6. We want to distribute 3 items per store. So 6 -1 over 3 plus 1, and we get 2. So we need 2 stores. Each gets 3 items. So now that we have talked about the pseudocode, I just quickly convert the pseudocode into C# code. This is provided in the GitHub links below. From that GitHub link, you can see also a Python version of the code. Everything's pretty much straightforward, and let's test whether this works. And it looks good. Next time, we will do another binary search problem. Hope to see you then.